Greetings again, everybody, and welcome to Ariane's 200th Take 2. Joshua Jampol back again with Alex Madembasi, Program Director with Ariane Space. Hi.
Hi, Josh. Good evening, everyone. Good evening to all of you, wherever you are in the world, watching our website, and welcome again to Kourou.
We have a lot to talk about. Again, we're going to go first, of course, to Ariane Space Chairman and Chief Executive Jean-Yves Le Gall for a word on everything that took place since we last left you last night.
Good evening. Second attempt for this historic 200th Ariane launch, which will orbit ATV-2 Johannes Kepler. It's the second attempt because, as you saw last night, during the final 7-minute fully automated countdown, the onboard computer spotted a difficulty. That is, a piece of information that was not what we expected, and the countdown was interrupted. As we're going to the International Space Station, we have to leave the ground at a specific instant, so there's no launch window. This is why we had to stop yesterday evening. Immediately after operations ceased yesterday, our teams started working to understand, analyze, and repair the origin of that difficulty. Now the Ariane 5 launcher has been fully restored to its operational condition, and the countdown has started. If everything is all right, we should resume the final countdown 7 minutes before launch. Launch is a little earlier tonight. Yesterday it was at 19 hours, 13 minutes, 57 seconds. And this evening it will be at 18 hours, 50 minutes, 55 seconds. If all runs well, we should start the final countdown, and I hope today we'll run it till the end. I leave you now to watch the Ariane 5 ES launch of ATV-2 Johannes Kepler.
So with a short delay of 24 hours, we're set to go with the first launch of the year, the 56th Ariane 5, and of course the 200th Ariane, the fourth launch in 4 months, as a matter of fact. Looking into the flight directorate here, Alex.
Yes, the flight directorate, the board who took the decision to suspend the activities yesterday and to reschedule the launch since we had no launch window. It's not an easy decision to take, but most important is to keep the launcher and the satellite in safe conditions and good health. 1 day delay is not much compared to the importance of the ATV mission. We're now ready for launch.
Ready for launch coming up in 11 minutes for the first launch of the year. You saw Edward Perez there. Edward Perez is the sort of the technical memory.
The CTO of Ariane Space.
Top technical person. You're going to be hearing next from the Launch Operations Manager and the Mission Director all about the launcher campaign for Flight 200.
Well, it is indeed a specific campaign because it is the 200th Ariane launch. It started very early, immediately after Flight 197 last year.
These hard-working teams were involved with assembly of the Ariane 5 since October of last year. They took advantage of the lessons learned from the first ATV flight. This saved time where work on the passenger was concerned. Flight 200, however, had certain restrictions, like all Ariane launches preceding it.
We started with the preparation of ground facilities and of the launcher, and went on till the ATV-2 reached the BAF. We also worked between Christmas and New Year to be ready to receive Johannes Kepler ATV-2.
ATV-2 has a special cargo access device to load last-minute items. It's the first time the European Space Agency has used such an element. Over 400 kilograms will be loaded through the International Space Station hatch, with the ATV in the vertical position atop Ariane 5. This gives flexibility in adapting the cargo to the needs of the space station.
Last-minute freight integration allows NASA to integrate the equipment necessary for the station as late as possible, knowing that nominally most of the freight is integrated 3 months before launch. Entering the module generates access constraints in terms of cleanliness and contamination. The European Space Agency implements procedures to make sure the operator's environment is fully compliant when he goes down into the module.
Another restriction, this launch is programmed for a fixed liftoff time. No launch window.
The last phase, that is the transfer of the launch vehicle to the launch pad, followed by filling, requires full compliance with the schedule because tonight we have no launch window.
After completing its final checks, Ariane 5 was given the green light to move to the launch zone. This transfer is done the day before liftoff. Riding on the launch table specially conceived for it, Ariane makes her way slowly on the rail track, pulled by a special truck, to its position on the launch pad. Here, it awaits the final countdown.
And Ariane 5 awaiting the final countdown on this very cooperative effort tonight from all the European partners and beyond, and we'll be hearing from all of them later on. But for now, Alex, the very green status panels.
Yes, so tonight we all hope that it'll stay green until the lift-off time. So again, the panel showing the health status and readiness status of not only the launcher itself, but also the ATV and all the different means of the launch base which are participating to the launch tonight.
The space base is a big one, and all these services, downrange, telemetry, safety, the satellites, weather, all of them, sending their information here into Jupiter Mission Control, which is why we call it the nerve center of the space base. And they come into two gentlemen, whom you're about to see, the mission director and the DDO, the range operations manager. And there's the mission director.
So Jean-Marc and Damien, who are the key persons of the launch campaign. They are coordinating all the operations all throughout the launch campaign.
À tous de DDO, attention pour la séquence finale lanceur.
The DDO who calls out the milestones in the campaign is going to call out the final automatic sequence at 7 minutes.
Top H0 moins 7 minutes.
All right, there we are. We made it into the final sequence, also called the automated or automatic sequence. These are the final moments, I guess, of final countdown. Looking here into the program director area, Alex.
Yes, Christophe Bardou. Just some word on the automatic sequence. From now on, any activation of the launcher or any ground system is totally automatic and decided by the computers.
Under the fairing tonight, 20 tons. The ATV, the second of 6 or 7 ATVs going towards the space station. Basically, a cylinder 10 meters by 4.5 meters, 22 meters with the solar panels deployed. That comes at the very end of the mission, about an hour from now. In two parts, basically, there's a service module and a cargo module. Service module with the propulsion systems, avionics, and also, I believe, some of the propulsion in there. Propellants, I should say.
Propellants, yes.
And the cargo, of course, bringing up needed items to and supplies to the ISS. 20 tons in all. Shot of Jupiter. Jupiter's in two parts. There's the operationals. Here are the program directors. This is your job, actually, isn't it?
This is, yes, the program director, Christophe. And here is the counterparts from the ATV, Charlotte and Nico Detman, the DMS. Christophe's work is the program director. He's handling the contracts from signature up to the launch.
Dealing with the customer. You're the customer interface.
He's the customer's interface for Ariane Space.
And that is your job. So you start on a new contract, 18 months before liftoff?
For a normal telecommunication satellite, it takes about 18 months to prepare for a launch. Of course, for a scientific satellite, it may take much longer.
That's a little different, yeah. And then, of course, you have all the reviews after launch and everything.
Yes, we have a very accurate and detailed analysis of all the flight data before the next launch is taking place.
So you're very busy. So I'm glad you took time to do the broadcast today.
I'm always very busy. Thank you to remind me that, Josh.
We saw under the fairing. Take a look, Alex, and read off some of the figures on the launch vehicle itself.
Yeah, the two big boosters, which are manufactured here in Kourou, prepared and assembled here in Kourou. The main stage, main cryogenic stage, the big stage with the cryogenic propellants. And the upper stage EPS. We'll talk a little bit more about this stage later. And on top of the EPS, the VEB, the brains of the launcher, with all the electronics and onboard computer and ATV, enveloped by the fairing, the long fairing.
All right, coming up on 4 minutes. This is roughly where we got stuck last night, at 4 minutes and 1 second exactly.
Yes, now we've passed the pressurization of the propellant tanks, so the filling process has been stopped.
We had a last-minute weather check at 10 minutes, didn't we, Alex? And they gave us a green for the weather?
Yes, we had a green already at minus 20 minutes, and we'll have very last. We had the last weather report at minus 10 minutes, which was green as well.
It was raining earlier in the day, but you can see the sky has cleared considerably, and we should have fine weather for launch. We should have some fine pictures at liftoff on this very first launch of the year. Up at the Launch Control Center, what's going on?
The Launch Control Center is now under the heading of Klaus Zell, our launch operations manager. He's conducting the Ariane Space Launch team and conducting the last operations and monitoring everything which is going on, happening on the launch vehicle.
They monitor all the checks that take Ariane down to liftoff, not beyond. Is that right?
Yes, they monitor all what's happening on the launcher and all the information coming from the different checks.
Now, how many people are up there? I know there are 3 teams. How many people?
Around 150 people, maybe 200, including all the people in charge of the ground installations maintenance.
I think there are 3 teams basically up there, coordinating the campaign and the countdown, guaranteeing flight readiness.
Yeah, there may be even 2 teams preparing for 2 different launch campaigns, because we can prepare a launcher for the next flight and while being about to finish the campaign of the previous one.
All that taking place about 14 kilometers away from here, where we are in Jupiter. You can see Ariane on the pad. Coming up on 2 minutes, we're still green. That's the color we want.
Green, which is very good news.
What's happening now?
Now, what's happening is that we have the very last operation on the launch vehicle, which will progressively become totally autonomous from the ground systems.
This is what basically happens during the synchronized sequence from the 7 minutes down to liftoff is power. Am I right in saying power passes from the ground control over to autonomous onboard computer control?
Absolutely.
Okay, so that is what's happening now. If we bring the camera back into Jupiter, you'll see people starting to wander out onto the terraces. There they are. They're going out. There are 2 terraces on either side of us here, observation decks, and the VIPs and invited guests go out there usually about this time, and they have a bird's eye view of the launcher lifting off, passing right over our heads on her way. The DDO will call out the 1 minute mark in just a moment, and we'll be into the final 60 seconds of Flight 200.
De DDO. Attention pour H0 moins 1 minute. Top H0 moins 1 minute.
All right, we're into the final 60 seconds of the first launch of the year. Remember, you can follow all the action on the website. You have the address right there. The ignition sequence, tell us about that, Alex. You'll hear the DDO call out allumage,
yes,
which is ignition.
You'll see the flame under the main engine, Vulcan. So we shall ignite the engine and check it for 7 seconds.
That's the main engine.
That's the main engine. And when everything's fine and with the check is okay, then the ignition of the boosters and the actual liftoff.
Okay, so you get main engine lights up first, computers check out for 7 seconds, all the pressure, testing it on the ground, and then the boosters go. We'll let the DDO, we'll call out the final countdown, and be back after Ariane has cleared the tower.
À tous de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, unité. Top, allumage Vulcain. Confirmé. Top, allumage EAP, décollage. Les paramètres à bord sont normaux.
Beautiful there. Ariane off on her way with just a 24-hour delay, leaving a trail of gold as she rises into the sky over French Guiana at 18:51 local time and right on time. Ariane began her mission.
And right on time. So we had a mass at liftoff of 773 tons, including 554 tons for the sole boosters. The boosters which give a very strong initial acceleration that will increase velocity from 0 to 7,200 kilometers per hour in about 2.3 minutes. That's 4,500 miles per hour. So after booster separation, which will occur in about 2 minutes, the launcher will have lost about 75% of its liftoff mass. The boosters will fall down into the Atlantic Ocean in a zone which has been secured by an international advice to maritime navigation.
Ariane burning now 5 tons of fuel per second. That's 2.5 tons in each booster per second. The EPC, also the core stage, as it's called, is burning another 300 kilos of fuel per second. All that adds up to roughly the equivalent of a dozen Airbuses. She's now following the program in the onboard computer, which gives all the orders, including stage separations, which we will soon see. 4 powered flight phases tonight. We're in the first one, the main engine and the boosters. And the boosters, as Alex said, they're going to burn for another maybe 20 seconds. Alex, take a look on the left, the upper left screen. Can you give us a description of the curve, please?
Yeah, we see the simulated flight trajectory, which is computed by using very accurate mathematical models of the launcher and the ATV, and by application, of course, of the Keplerian laws for the ballistic phase.
Which we're going to hear about a little later.
Yeah, a little later.
All 3 of them.
So the Mach, which follows...
DDO has just called out the separation of the boosters. You can see what that looks like. There's another one out of camera range on the left, but they fall back down right on time at about 64 kilometers up, I think. They fall away from the shore. People streaming back in from the terraces, you can see in the background there.
Yes, now to follow the actual flight. And now we're expecting the fairing separation.
That's the next milestone. Minutes. You can see the cursor crawling up on the upper left. I don't know if you can read it. Sep Quaff, it says separation of the fairing. On the lower left, Alex, can you describe what the bottom lines are?
Yes, we have the real-time information from the launcher of the velocity and the altitude, and also the angle of the telemetry antenna with respect to horizontal.
So you see the altitude. The altitude is 102 kilometers. That's the second line. So we're above the atmosphere, which is where we can separate the fairing, and the DDO will call out that milestone in a moment. We are in the second.
Largage de la coiffe.
There it is. Largage.
There it is. So we don't need the protection of the fairing anymore. We have crossed the atmospheric layers, and then now we don't need this 2 tons weight anymore.
There are actually 2 halves. One half, like one of the boosters before, was out of.
Yeah, it's cut vertically and horizontally.
Everything is perfect on board, says the DDO. The ATV now under the fairing, exposed to the elements. And we're going to go now to the next part of the broadcast, which is the latest news from Arianespace, and there is a lot of it. So take a look.
Ariane ended 2010 in style with its 6th successful launch on December 29th, delivering 2 telecommunication satellites, Hispasat-1E for Spain and KoreaSat-6 for South Korea. It was the 41st straight successful mission for the European launch vehicle. 2010 was a big year for Arianespace, with 12 contracts signed for Ariane and 7 for Soyuz. In all, 6 successful launches for a total of 12 satellites. 2011 promises to be as big, with Soyuz and Vega bringing their launch services to the space base. Tokyo, January 19th. During the EJBRT roundtable of Japanese and European industrialists, Jean-Yves Le Gall met with Japan's Prime Minister, Naoto Kan. The meeting underscored strengthening cooperation between Europe and Japan in matters of space research and in commercial space. Eutelsat has signed with Arianespace to launch one of its new satellites in 2012. This is the 26th contract between the 2 partners. Jean-Yves Le Gall and Dr. Volker Liebig of the European Space Agency also signed for launch of Sentinel-1A, an environmental monitoring satellite, for December of next year. Baikonur, January 28. The Soyuz once again successfully lifted off from the Kazakhstan base. It was launch number 1,766 of the legendary vehicle. Meanwhile, here in French Guiana, Soyuz is preparing for her maiden voyage, set for the second half of this year. Work on the launch pad is nearly complete. Vega 2 is set for her first flight. Qualification tests continue here in French Guiana.
We're now in the stage of combined tests to be completed by the end of June. The mechanical tests are completed, the launcher module is now integrated into the Vega gantry, the electric tests are completed up to 50%. Now remain the fluid tests with the filling of the Avon, the fourth stage of Vega with its own propellants. Very delicate phase which will take place under the responsibility of Ariane Espace in French Guiana. During those next few months, the launch system review should also take place. The steering committee is planned for the end of June. The dates of the qualification flight campaign will then be known. It's planned for the early summer. The docking with the first Vega flight is planned for the autumn of this year. So let's keep our fingers crossed and good luck, Vega.
Ciao.
We are in the second of the powered flight phases. The main engine burning alone, it'll burn for between 8 and 9 minutes.
It will have burnt about 149 tons of liquid oxygen and 25 tons of hydrogen. And then let's learn more about the trajectory by Alexis Macaire.
Tonight's flight is using an Ariane 5 ES version. Storable propellant aboard the upper stage will allow it to reignite several times, something essential for placing ATV-2 into its final orbit.
Unlike the other standard GTO flights carried out with an A5 ECA launcher with only one ignition of the upper stage, here with the ATV there will be two ignitions of the upper stage separated by a 45-minute-long ballistic phase. The first EPS boost will last 10 minutes. It is carried out above the Atlantic Ocean within reach of the Santa Maria station in the Azores. At the end of this EPS-1 boost, the launcher is already in a stable orbit with a perigee at 140 kilometers and an apogee at 260. This flight will go on above Europe, then Asia, until Australia. The EPS is ignited again. The EPS-2 boost will last 30 seconds and it will then reach the orbit targeted for this mission, 260 kilometer circular altitude. After the EPS-2 boost, the composite enters a stabilization phase.
This stabilization phase will let the ATV control center in Toulouse make contact with the ATV-2. Then separation can occur. On its own, the ATV will circle the Earth for a week before catching up with the space station 22,000 kilometers ahead of it. It will then have reached an altitude of 350 kilometers and be ready to dock.
You heard Alexei in the film talking about the Santa Maria ground station. That's an ESA tracking station, rather new one, joined the system in 2008. Not used a lot, but it was used for ESA's Envisat, which was launched by Ariane in 2002, Flight 145, and it's going to be used also to receive launcher telemetry for the upcoming Galileo GPS launches on Ariane or Soyuz from the space station. The DDO has just called out the extinction of the lower stage and the separation of the lower stage. You can see what that looks like up there.
Waiting for the ignition of the upper stage.
The first upper stage burn.
There
it is. He's called it out
there
right
it
on
is.
time. Those are three commands given by the onboard computer: extinction of the lower stage, separation of the lower stage, ignition upper stage in about 12 or 13 seconds. Now this is the everything normal. He says the first ignition will burn for about 8 minutes. There are actually 3 burns. 2 of them concern the ATV. 1 of them does not. It comes about an hour after our broadcast. I don't think we're going to be here. But the lower composite has done its work now. The launcher reaching its targeted position for extinction of the main engine. Everything okay on board?
Yes, the EPS. The EPS is burning. It's used on this ES version for its capability to be reignited during the flight, and then to perform the 2 boosts which are necessary for the ATV mission before a third one, which will be the re-entry into the atmosphere and destruction of the upper stage, leaving no debris in space. But now we are listening to Jean-Jacques Dordain, Director General of ESA.
Johannes Kepler is the second ATV. Jules Verne was the first one. It was a great achievement. But this one is a production ATV, which makes a big difference, since it's the first of 4 to leave over a 1-year period. It's an exceptional and unique vehicle for ESA, because it's partly a launcher, a spacecraft, partly an orbiting infrastructure. And even though it's an automatic vehicle, it's compatible with a crewed infrastructure. It's also a unique vehicle for the station because it's the heaviest truck bringing freight on board and which automatically docks with the station with great accuracy. It's the outcome of a tremendous work undertaken in industry all over Europe under the leadership of Astrium in Bremen for the production part. It's also cooperation with partners, since we need all the partners of the station, especially the Russian partner, since we dock with the Russian part of the station. And indeed, it's also the outcome of the continuous support of all the member states. And I'd like to thank them all for their support and their patience for this exceptional event.
6 minutes left in the upper stage's first burn. Ariane performing flawlessly. You can see on the bottom left our altitude is 146 kilometers and our speed is 7.2 kilometers per second. Johannes Kepler, Alex, he gave his name to the mission tonight. Tell us a little bit about him.
He was born in 1571 in Germany. He's a contemporary of Nicolas Copernicus and Tycho Brahe. He's a German mathematician, astronomer, and astrologer, and a key figure of the 17th century scientific revolution. He has already proved himself at the age of 28 as being a superb mathematician and earned a reputation as a skillful astrologer as well.
And we're going to have a look at his 3 basic laws coming up. That's coming up a little bit later on. For now, another film on the ATV, a look about what it's carrying.
"600 kilograms heavier than the Jules Verne, which had itself established a record, this second ATV is the heaviest spacecraft that Europe has ever launched. This is largely due to a performance increase of Ariane 5 with its new welded boosters, already used several times on Ariane space commercial flights. But the overall ATV capacity has been increased. The 8 internal racks of its cargo carrier section have been redesigned and optimized in weight and volume. Depending on ISS requirements and on solar activity, the average ATV loading turns around 6 tons. But the Johannes Kepler will do much better.
The current manifest is that we are uploading 7.1 ton. It will be fully loaded almost up to the last gram.
On this manifest, 1,600 kilograms of dry cargo. It includes 435 kilos of food, 70 of astronauts' belongings, ESA's geoflow experiment to study convective flow patterns of liquids, and spare parts for ESA's Columbus laboratory and for NASA's ISS modules. Also loaded 3 video cameras to be used for ESA physiology experiments and several liquid waste boxes to store non-reusable parts of the station's water system. And for public relations, a few stickers. Most of the dry cargo was loaded last September. However, this second ATV mission will make use for the first time of its late access ability. 28 different bags, some 430 kilograms to be added at the last moment.
Since we have closed the back entrance of the ATV, the late cargo loading takes place in the final assembly hall. We will open the Russian docking system interface, and the person will descend into the ATV through the hatch, and then will stow these bags in their designated locations.
The bulk of the cargo, however, is propellant. Except for the water tanks remaining empty on this mission, the other reservoirs are brim full. 4.5 tons of propellant to reboost the ISS, 850 kilograms of fuels to transfer into the Russian FGB module, and 100 kilos of gases, air, oxygen and nitrogen. Everyone remembers the pictures of the streaking debris when the Jules Verne disintegrated as it plunged towards the Pacific Ocean. The perfectly controlled re-entry had been monitored and filmed by 2 aircraft. No aerial surveillance this time, but on its descent the Johannes Kepler will have an unusual passenger. A 4-kilogram, 30-centimeter diameter conical picosatellite will record and send back to Earth details of the breakup, recording the ultimate moments of the second ATV mission.
Alex, we're in the upper stage burn, and this version of the Ariane, its upper stage, is called the ES. Now, how is the ES different than the others?
So the EPS upper stage was used for the very first versions of the Ariane 5. And it uses storable propellant instead of cryogenics. And the engine has the capability of being reignited, which is not the case for the upper stage ESC with the cryogenic oxygen and hydrogen. So we kept the, after we decided to have only one version with the powerful full cryogenic launcher, we decided to keep this stage for specific missions and especially for the ATV missions. So this capability of several boosts is aiming at reaching this very specific orbit of the ATV, which is inclined at 52 degrees.
So we need the reignitable upper stage for this mission.
Yes.
As we mentioned, there are going to be 3 upper stage burns. The first one is very shortly going to be shut down. You'll hear the DDO call that out. And there it is.
It's about 9 minutes of burn. And the second one will be very short, 30 seconds.
30 seconds, yeah, that comes...
Début de la manœuvre d'orientation en phase balistique qui durera 42 minutes.
All right, we're into the what they call the ballistics phase. Jean-Yves Le Gall is going to say a few words
to la première partie de la mission d'Ariane 5 ES.
Ariane 5 ES mission is over, and now the ballistic phase starts. The EPS, the storable propellant stage of Ariane 5 and the ATV-2 Johannes Kepler will soon fly over Europe, Southeast Asia and Australia for 42 minutes as a whole. Then the EPS, the upper stage, will be ignited again during 4 minutes, and at 19 hours 54, ATV-2 Johannes Kepler will be separated from Ariane 5. So see you in something like 45 minutes to see the second part of the mission.
Okay, there we are. And the second part of the mission is going to begin with a film on the lessons learned from the first ATV-1, which went up, of course, in 2008, and the ESA and Arianespace and all the other partners put those lessons to good use for this launch.
Launch teams from Arianespace and ESA took advantage of experience gained from the first ATV mission to make today's run more smoothly, and Ariane's experience in launching commercial satellites has allowed it to meet the record performance demanded by the 20-ton ATV-2.
Même si elle est sensiblement plus complexe, la mission de ce soir a bénéficié de l'expérience acquise au fil des lancements commerciaux et acquis lors de la mission ATV1. La principale différence est la masse d'ATV, 20 tonnes et 60 kg pour ATV2, alors que ATV1 ne pesait que 19 350. Ceci est le résultat d'améliorations de performance intervenues entre-temps sur le lanceur. En particulier, à l'issue du lancement d'ATV1, nous avons effectué toute une série de retours d'expérience, que ce soit pour les opérations au CSG ou pour l'analyse des missions. Ceci a largement contribué à fluidifier la préparation de cette mission, et tout ceci resservira bien entendu pour la préparation des missions ATV suivantes, en particulier ATV3 dès l'année prochaine.
The ATV is a supreme technical achievement, but also a great human adventure, and one that's brought together people and partners from around the world.
Well, regarding ATV, the main equipment suppliers are coming from 10 European countries, plus US and Russia. The small ESA ATV team is composed of 9 different nationalities, so I hardly can imagine a project which is more multicultural than ATV. And that's actually why I love the project and what makes it very interesting and efficient.
The ATV is Europe's contribution to the International Space Station and one that has mobilized the entire international space community.
So, as you know, the ATV is part of the ISS exploitation program. It is actually part of the so-called US segment of the International Space Station, but it is docking to the Russian part of the station. And we need also other vehicles like Japanese vehicles and Russian vehicles in order to maintain this project, which is the largest international project which has ever been created by human beings.
Alex, the ballistics phase involves a telemetry loss, as I understand it.
Yes, we're flying over Europe, and then Ukraine, Kazakhstan, and then Asia, and to reach Australia. All along this track, we do not have ground stations, and then we will have no telemetry signals.
But so that's normal. That's planned for.
Absolutely right? Normal. So you will see that the numbers at the upper left is frozen.
We'll get back to the numbers, but tonight's scientific mission is the latest in a long series, and we're going to take a look at a film that recaps those.
Arianespace, the world leader in launch services and solutions, also leads the way in space science. It has contributed to scientific research ever since its second flight back in 1980, and it continues to serve the scientific community. Since then, the Ariane family has launched dozens of satellites, probes, and spacefaring ships that have helped expand our knowledge of fields as diverse as astronomy, the magnetosphere, ocean currents and their circulation, the study of comets, general Earth observation and the environment, and meteorology. These satellites had names like Giotto, Hipparcos, Rosetta, Herschel Planck, Envisat, XMM, Topex Poseidon, and the Spot series. Whether in Earth orbit or in sun-synchronous orbit, these valuable payloads have helped place Europe at the forefront of contemporary science. They have given us invaluable building blocks for the future study of not only our own planet, but the entire cosmos as well. From the first Ariane 1s to today's powerful Ariane 5, Arianespace continues to play its part in our ongoing quest for achievement in all fields of scientific discovery.
Alex, you got interrupted on your story of the telemetry loss. Go ahead, because it's very important.
Yes, so I said that there is no ground stations all along the track, but due to the fact that we have a ballistic phase, we know exactly where the launcher is, and we know exactly when we shall recover it with this signal. We have a mass memory on board, which records all the flight data, and we shall recover them when we get the telemetry signal in Australia. And all this data will be downloaded for further analysis.
That comes afterward. It doesn't come in real time. Is that right?
In real time, we record on board, and then we shall download.
Okay, more on the ground stations tracking the Ariane 5 and ATV, the subject of our next film.
After liftoff, the launcher and its passenger may be lost to casual observers, but they are closely followed by teams around the world, with ground stations gathering radar and telemetry signals, giving vital information on both launcher and passenger.
The launcher must be monitored for the whole propulsion phase, starting from the coast of French Guiana and Galileo telemetry stations to get all the data from the launcher. Then we set up a naval station located on a boat, MN Toucan, which belongs to Arianespace and which is exactly halfway between the Azores and here. Then we fly over the Azores when we have the first EPS extinction. From then on, we are in the ballistic phase for about 45 minutes. During the ballistic phase, we have the support of DGA. Their radars will give us excellent visibility of the position of the launcher. DGA, the French MOD, is a long-time and privileged partner of CNES in space activities, especially for military programs like Helios, for which CNES will be delegated project manager for the space part of the program. Once we leave the DGA visibility, we go on to the Perth visibility in Australia, then Warrior in New Zealand. And we had to set up a station in Warrior, New Zealand to have visibility of the second EPS propulsion phase and the separation of the ATV. You know, it's original because it highlights the planetary and human dimension of this campaign. Also the fact the antenna was set up by our partner OTB in South Africa, an African antenna with Ariane 5 reception equipment from CSG. This highlights the human dimension of this campaign.
All right, Alex, you told us all about Kepler's life earlier. Now let's hear about his laws. Law number one.
Law number one. In Kepler's time, everyone believed, including Copernicus, that orbits should be perfect circles, but a circle is in fact an ellipse with very low eccentricity. So it was not obvious that the orbits are elliptical. Thanks to detailed calculations for the orbit of Mars, Kepler deducted its elliptical shape and inferred that other celestial bodies, even farther away from the Sun, have elliptical orbits too.
All right, that's the first law. The second and the third laws coming up a little more. But for now, tonight's launch represents a partnership with the Ariane Space and industrial partner EADS and an interview with their chairman.
Today is a great day for Astrium since we have a conjunction of two events. The first one is the 200th Ariane launch after 41 successes running. Astrium can be proud of this success. And this is not just sheer luck. This is the fruit of a quite extraordinary and long industrial work done all over Europe to ensure the launcher reliability and performance under the responsibility of Astrium, Ariane prime contractor. I would like to take this opportunity to really thank from the bottom of my heart the women and men who are at the origin of this extraordinary success at Astrium and in all European industry. But let me also thank the European Space Agency and the national agencies, in particular CNES and DLR, that have made this success possible. They have trusted us and provided the means for that success. The second event is the launching of the second ATV Johannes Kepler, after the extraordinary success of the docking of the first ATV, Jules Verne. Again, let me thank the Astrium teams, of course, the ATV prime contractor, and all our partners all over Europe. So, Ariane, the ATV, these are two examples of the European space industry, of its exceptional technological expertise. I want to really thank the European governments who have launched this human adventure of Europe in space. I say launched because this European adventure in the conquest of space is just starting. This is the beginning of all that space can offer to the men and women of Europe. So let us go on now. Let us develop Ariane further. Let us learn all the ATV lessons in particular. You can really believe in our ambition. You can trust us.
Et vous pouvez nous faire confiance.
All right, Alex. Kepler's first law, elliptical orbits. The second law, I think, is a little harder to describe. Good luck.
A bit more difficult. The line joining a planet and the sun sweeps over equal areas during equal intervals of time. This, of course, perfectly applies to the motion of a satellite around the Earth. It simply means acceleration of the satellite towards the perigee and deceleration towards the apogee. The velocity is not constant on an ellipse, except for the particular case of a circular orbit, the geostationary satellites.
All right, you did very well. The ATV has its own control center in Toulouse, and that's the subject of our next film. Take a look.
Since the earliest days of spaceflight, the French space agency CNES has accumulated a significant expertise, not only in the conception of satellites and manned spaceflights, but particularly in all aspects of spacecraft operations in orbit. The creation of the ATV Control Center was decided in 1998 and installed in 2002 at the CNES Technical Center in Toulouse. It has the responsibility of conducting, on behalf of the European Space Agency, the coordination of all in-flight phases of the automated transfer vehicle. The Toulouse Centre coordinates all the control facilities involved in an ATV mission. Those related to ISS operations, like the NASA one in Houston or the Russian one in Moscow, not forgetting the astronauts themselves in the International Space Station, and also the ESA Ground Network Control Center hosted in the Columbus Center in Germany. The inaugural flight of the ATV in 2008 required 2 demonstration days to validate the vehicle's automatic rendezvous and docking technology and its collision avoidance maneuvers. A Jules Verne mission patch prominently displayed today in Houston testifies to that first mission's success. Okay, it's anecdotal, but it proves that the ATV is now truly part of the Houston Center, but moreover that it's entered into this restricted sphere of manned spaceflight activities. For each mission, the ATVCC draws up with its partners the mission timeline and the complex procedures and validates all the required control systems. After launch and release of the spacecraft, it tracks every phase of the flight, including the rendezvous and docking with the ISS. This covers, for instance, the monitoring of the solar array and antenna deployment, and the firing of the ATV's engines to change and raise its orbit to that of the orbital outpost. Preparing an ATV mission can take 1 year, and with the Johannes Kepler mission being the first in a series of regular flights, and with new engineers joining the teams, CNES and ESA have this last year geared up to the prospect of these recurrent missions. We've created what we call a training academy, which is a set of classes, practical and theory, individual lessons, and as a team, which include rehearsals with our partners, so that we are ready to conduct these operations. Come the day, the engineers at each console can react instinctively to any incident, in harmony with their colleagues, and totally calm, however difficult a situation may be. At the end of the mission, the teams at the ATVCC will supervise the vehicle's undocking, and they will initiate the last maneuvers which safely deorbit the spacecraft, entailing its disintegration in the atmosphere over the Pacific Ocean. Even if numerous safety measures have been built in, there is still tension in the control rooms for each phase of the flight. It will never become a routine job, particularly as human lives, that of the ISS crew, is involved. But it is also, for all concerned, a magical moment. It's magical to experience the sight of an ATV approaching the space station in real time on a big screen, in a control room that is vibrating at the speed of the ATV itself. Even when I watch those pictures again from 2 years ago, I have shivers down my spine, so I can't imagine anyone else reacting differently, particularly those for whom it's the first time.
Alex, you are go for explanation of Kepler's third law.
Number 3.
Yes.
So, third law was published by Kepler in 1619. It says that the square of the period of revolution of a planet is proportional to the cube of its mean distance from the sun. So you can easily, from your kitchen, preparing your breakfast, calculate the time of a complete revolution of a satellite around the Earth.
That's pretty good. I think I've got that now. The third laws about revolutions on the Earth. Very well done.
Let's give it a try.
A film now on another partner, NASA's work on the space station. You'll be hearing from Michael Suffredini, their program director.
It's really interesting what's happened over the years since the partnership was formed and we started building the ISS. In the early years, the U.S. expected that the shuttle would fly for the entire life of the ISS. With the decision to retire the shuttle and to move on to other systems for resupply, the ATV has become a critical part of our capability, whereas before it was important to have particularly the propulsion capability that it carried. Largely it was redundant to what shuttle could otherwise fly to ISS. So when the decision was made several years ago to retire the shuttle, both ATV and the Japanese version, the HTV, became critical parts of our logistics resupply. And the vehicles that we procure in the U.S. to supply the ISS supplies basically the balance of what is remaining after the ATV and the HTV do their function. So in that sense, it's become critical to the well-being of ISS. And as we evolve ISS and keep it on orbit for many years, we will. The one thing is certain: we'll have to continue to resupply, and a consistent resupply chain is mandatory for the health and well-being and the utilization of ISS. And so, when people ask the question, what do you think of what role does a vehicle like ATV play to ISS? It's a simple answer, and it's not being dramatic. We can't survive without these vehicles, and ATV is a key part of that. And so for the livelihood of the ISS, in order to keep 6 crew on board and have them do all the research that we need them to do with the platform that we all built in low Earth orbit, we have to have the ATV there doing the job that we're relying on it to do. To date, it's done very well, and we expect the remaining vehicles to do just as well. We look forward to having it on orbit.
Alex, we mentioned some of the lessons learned from the ATV-1 going into tonight's launch. Can you elaborate?
Yes, we have a lot to learn from each campaign. So the lessons learned from ATV-1 qualification flight have permitted to improve the operational procedures and to overcome the technical difficulties that were encountered at that time. This is a typical way of always improving our knowledge by taking lessons from experience. We have implemented a quality management process which addresses specifically the lessons learned aspects with the customers.
All right, this ATV-2 is eagerly awaited by the astronauts on board the ISS, and they sent us this message from space. Watch this. I think you'll find it interesting.
The other reason the ATV is very important to us is because it, unlike some of the other vehicles, like the HTV and the commercial vehicles, it provides a capability to reboost the space station to adjust its orbit and also for debris avoidance. So it's very, very important to the International Space Station.
As a crew, we're really looking forward to having the ATV come aboard. It's a bit different than our next supply ship, which is the Japanese supply ship, or HTV, in that the HTV is a ship that comes up, approaches the space station, hovers in place outside the space station, and then Paolo and I will capture that HTV with the robotic arm and then attach it to the space station. Now, ATV is an autonomous vehicle that docks to the space station without the robotic arm. And I'll let Paolo tell you about that.
ATV points the way to the future because it looks like technology that we really need to develop if we want to go beyond the moon and go towards Mars and everything. We need to be autonomous we need to rely on the machine being capable of carrying out this very important task. In fact, the rendezvous is extremely complex, and when you see such a big spacecraft arriving towards the station at a precise distance from the target, you really figure out how important it is to be capable of doing this activity in a good way. Of course, we are expecting ATV because it has a lot of supplies for the station, but also because it contains a lot of personal item, clothing for us. So we are really waiting for this vehicle to come, and we really would like to thank the European industries and European engineers that have designed and built this vehicle. We'd like to thank the launch team that is there in Guyana, launching the vehicle, and the team that is in Toulouse, ESA, Ariane Space, all the teams that are there working all together for this vehicle.
So a little fun in space from our astronauts on board the ISS. There are 6 of them on board now, and those were the 3. You saw Paolo Nespoli speaking last on the left. He's from Italy. It's the first time a European astronaut is on board the ISS for an ATV mission. There was no European astronaut 3 years ago for the Jules Verne. The European astronauts train at the European Astronauts Center in Germany. It's outside of Cologne, Köln, if you speak German. They've been making regular visits to the ISS ever since about 2001, I think. We've had German and Italian and French and Spanish and Belgian and Dutch and Swedish astronauts. More on the ISS on this film. We'll be back.
Last November, the International Space Station, with its 14 modules, its maze of corridors, living quarters and laboratories, celebrated its 10th anniversary. Its assembly practically finished, 2001 marks a turning point for the orbital complex and its international partners. To maximize its use, there's now a consensus to keep it flying for at least another decade. Europe, for its part, with its Columbus laboratory, the multipurpose logistics module, the Node 3 connecting module, and its cupola observation and control tower, is eager to fully exploit with its astronauts all the benefits of this facility in orbit. And the ATV is a key element in this strategy.
We are talking here about the biggest international space program which has ever been designed. And ATV is the mean in order to pay our debts for the fact that our US partners are operating Columbus for us. So it's an obligation and it's a responsibility. And we need in total at least 5 ATVs in order to pay this debt. That includes Jules Verne, and we are on the discussion whether we need another one for the ISS extension.
With the space shuttle retiring soon, Europe's automated transfer vehicle will be the largest logistics vehicle for the ISS. Until alternative craft become available, there will also be the Russian Soyuz to ferry astronauts to and from the station, and 2 space freighters, the Russian Progress and the Japanese HTV. But with its 6 to 7 ton capacity, the ATV can load 3 times more cargo than a Progress, and the HTV has to be grappled and manually docked to the ISS. So the automated ATV is the most valuable asset for the continued operation of the space station, particularly when it is permanently occupied by 6 astronauts.
Taking care of everything.
The arrival at this time of the Johannes Kepler mission is of paramount importance for the ISS.
Since the shuttle has an interest to provide high upload, the ISS is flying a bit lower in order to allow shuttle to bring as much as payload to the ISS. So now with the shuttle retiring, ISS will be lifted, and this will be done by ATV, and it's a significant lift of about 30 kilometers, which ATV-2 has to provide.
ESA astronaut Paolo Nespoli will be fully involved in these operations, and particularly in monitoring the docking. The ATV-2 is the first of a series of closely spaced recurrent missions. Indeed, flight directors at the French Space Agency in Toulouse are already preparing for the 3rd ATV, christened Eduardo Amaldi, which is programmed for the spring of next year. Production-wise, the prime contractor, EADS Astrium, currently has 2 other vehicles on order after ATV3. ESA, with its member states, has started examining a proposal to budget for an additional vehicle. If Europe and its partners are to pursue medical, scientific and technology research in this orbital facility, and in future years use it as a staging post to send manned missions to the moon and further into space, then there are few real alternatives to adequately service the International Space Station during the next few years.
We're back in the Jupiter Center, and you can see that everyone is very concentrated on the mission. We are waiting for the telemetry signal to come back, and it will be the acquisition of the telemetry signal by the Adelaide Australian station, ground station. We shall have ignition of the second ignition of the EPS in about 10 minutes. And for the moment, you can see that all the information on the upper left corner of the screen is still frozen until the telemetry is recovered by the station. So a recap of the launch: we have the perfect launch right on time, although a bit cloudy weather. We could see the launcher and the boosters propulsion with separation here, separation of the 2 boosters, and then the EPC main thrust before separation of the 2 halves of the fairing, which protects the ATV during the atmospheric flight. And after this, the EPC, which thrust is obtained by the Vulcan 2 engine. After separation of the main EPC stage, we have the ignition of the EPS upper stage, on top of which we have the ATV, which is attached to its cylindrical adapter. And then extinction of...
We have a little time in the broadcast tonight. We don't always, but it's a special occasion. And we thought we'd take about 10 minutes to find out more about this marvelous machine, which is the ATV, how it works, and how it's going to rendezvous and dock when it meets the space station. And for all that, we thought, well, who better to ask than this gentleman right here. This is Jean-François Clairvoy of ESA, the European Space Agency. He's a former astronaut. He flew 3 missions on the U.S. shuttle, and he played a very important role in the design and the development of the ATV, particularly where the astronauts are going to be involved in its use. Jean-François, thanks for being with us.
Bonsoir.
Now, with us, of course, also you can see a model of the ATV. Now, Jean-François, before you take us on a guided tour and show us where everything is and how it's going to work and how it's going to dock, fill us in first on what exactly your role was in the design of, I think you call it the ATV astronaut interface.
Yeah, you may wonder why an astronaut was involved, although it's an unmanned vehicle. But of course, when it docks to the space station and when it is used on board, the crew is concerned. And my role in the program was to defend the interests of the crew, not only on the safety aspect, the operations, but also on the training. We had to design the training that is needed to qualify the astronauts. And something very unique to this vehicle, it requires only 2 weeks of training to qualify the astronauts, so they like it very much.
Now, I think we need now, before we go to the astronauts, a look at general overall description of the ATV. Now, my understanding, which is not very large, this is facing forward, this is where the docking goes, and here we have 2 parts, a cargo module and a resource module. Is that right?
Yes, you have to imagine that this is actually 10 meters long, so it's exactly the size of a double-decker bus in London. The half part, we can call it the resource module, like salle des machines in French. You have the thermal control supply, you have propulsion, you have electricity on the solar rays, and here the most important part, the most intelligent part, the brain of the vessel. And the forward part is the cargo. Part of the cargo is an unpressurized bay using for the fluids, the propellant and the gas, but the crew can access only the forward part, which is pressurized to access the bags, and also to control fluid supply. It's the manually open taps to supply water and gas. And of course, let's not forget the door, the forward part, the docking part.
Now, you mentioned that part of the bay there is not pressurized. Am I right in assuming that if it's not pressurized, the astronauts do not go in there?
That's true. The ATV was not designed for spacewalks around, neither inside. So if there is anything to do outside, the crew cannot walk. There is no handles like there are on the Hubble Space Telescope, for example, or other parts of the space station. They can only access inside in shorts and T-shirts inside the pressurized part. That part is not accessible to the crew.
Now, I asked the question because what happens if there's a leak or something, you have to send somebody in there to fix it and they can't go in, then you're stuck.
What is unique for this vehicle, although it's unmanned, it meets the safety requirements for human spaceflight. That means after any combination of any two failures, it is still safe. So if any problem, any leaks in this part, it will be handled by the ground, by the expert in the CNES control center in Toulouse, and it will remain safe even after one leak.
Okay, I think everybody's pretty clear on the cargo mission for the ATV, but there's another mission which is maybe not talked about as much. The astronauts, the 3 astronauts in the film we saw a moment ago, mentioned it, but very briefly, I'd like you to elaborate. They said we need the ATV to reboost the space station. Why do we need the ATV to reboost the ISS?
Actually, even at 400-kilometer altitude, there is still some atmosphere, so still air drag. So the space station slows down and lowers the altitude. It losses about 100 meters per day.
Is that because of gravity? Is that what you're saying?
Because of air drag. And even when the sun is very active, like it's coming in the next few months, it can lose up to 2,000 meters, 2 kilometers per day. So we need sometimes to rise the altitude to avoid the space station to re-enter the atmosphere.
Or the astronauts in the clip also mentioned another role the ATV has, and they called it debris avoidance. Now, how important is that?
In fact, we mentioned the forward part being the cargo, but on Kepler, most of the cargo actually is in here, in the tanks. It is not in terms of cargo supply to the space station, but it's a way to supply velocity. Using this propellant and the thrusters, ATV can, of course, rise the altitude, we mentioned that, change the attitude, but also change slightly the trajectory of the space station to avoid debris, natural debris or artificial debris. It has been done with Jules Verne in the past, and I expect that Kepler will do it also.
Okay, let's turn to the crew now, because that was your main mission. We don't have a lot of time, so I'll ask you a question in 2 parts. I'd like to know what the role of the crew is up until and during the docking. What do they have to do, and how do they have to do it? And to help you, we got some video.
So I will position myself relative to the vehicle, a bit like the crew is on board the space station. You can imagine the crew inside the Russian main module, the ATV coming on the aft part. And they work manually. Like you see on the screen, Peggy is holding a manual malfunction table. So they don't have a panel lighting what kind of malfunction they have. They design manually on this table what malfunction they have, if there is any problem, and which button they have to press. And at the same time, can you hold the microphone for me? Sure. Yuri is using this plastic wrench ruler to put it on the video screen to look exactly what distance is the ATV by looking at the actual angle on the TV screen. So the crew has a totally independent, manual, basic way to look at the distance and the range rate. And that's the way they can ensure safety, totally independent of all the electronics and the sensors.
All right, that's before and during docking. Now, the ATV is going to stay with the station maybe for up until 6 months. What is the role of the crew then? They bring cargo in and out? Is that it, or is there more?
So once they've ensured the proper docking of the ATV by just monitoring, I remind you that this is fully automated and controlled by Toulouse and the crew, just to add other safety layers. The ingress, we will see probably some video. The ingress by pushing the door, the ATV, and once inside, they just access the bags. First, I'm sure they will go to the bags where there are some gifts, mail and surprises given by the family. But of course, they access food, clothing, spare parts, experiments, tools. And if they need to supply water and gas, they can just open manually the tap in the back on the control panel in order to just get water and oxygen for the space station.
All right, the ATV is one of a number of ships that service the space station. There is the Russian Progress, and there's the U.S. shuttle, not for too much longer, however, and there's the new Japanese HTV. Now, how would you say that the ATV compares to those vessels?
In few words, HTV is about the same size, but it's only 15, 16 tons compared to Kepler 20 tons. And it doesn't dock to the space station, so it cannot reboost the space station. It is coming close to the space station, and the crew captures HTV flying a robotic arm and manually berths it to the US segment. But it has a big opening, so you can get a very big part goes through the opening. ATV docks like the Russian vehicle. We can say that Kepler is just like 3 times the size, the volume, the cargo capacity of a Russian Progress resupply vehicle.
And more sophisticated?
It is more sophisticated. It is more precise. That is not needed to be as precise. Can you imagine that this 20 tons vehicle docks with a precision of 1 centimeter when only 20 centimeter is needed? So it is not necessary for the space station, but it allows us in Europe to have the know-how for future exploration missions where we need more higher precision.
Very good. Okay, I think we have time for 2 more questions. My feeling is that the first astronauts, if I remember correctly, came to the space station in 2000, if I'm right. 11 years later, would you say that we're learning to live better in space or in a more regular way?
I think the crew has learned how to better organize the life on board, and I can tell you that's not easy to manage, especially to manage the waste. They are eager to have free volume available in the resupply ship to store the waste, because inside the space station it reduces the weight in the modules. But now there are 6 on board instead of 3, so they are more efficient to work on scientific experiments. The maintenance now is better understood, and we are ready to go further now.
All right, last question briefly, and I have to ask you this because everybody wants to know. You flew 3 times in space. I think there's one other European astronaut who logged more hours than you. What do you remember most? Is it a sight, a sound, a feeling, what? You got 30 seconds.
I think the strongest memory I have probably for the rest of my life is the view of the Earth. I was warned by American colleagues that I may find myself cry watching at the Earth.
Did you? Did you cry?
And on each of my flights, even with my colleagues, we were pinching each other. Can you see the luck we have to be here? And I felt tears in my eyes.
Even on the last trip, after so many hundreds of hours?
It is so moving. You know, we go around 16 times per day. Earth is so beautiful. You fall in love with your planet and you cry.
Well, I think you've inspired a whole new generation of astronauts to come follow you. And we are out of time. Thank you, Jean-François Clairvoy of ESA, the European...
You can call me Billy Bob. This is my nickname at NASA, yes.
Okay. We hope you enjoyed that look at the ATV with Jean-François. Many thanks to you. The mission continues, ATV separation coming up in about 4 or 5 minutes. Before that, however, the second upper stage burn coming up in about 1 minute. You'll hear the DDO calling out that. So for us, it's back up to the boys in the broadcast booth. Alex, Thierry, and Antoine, gentlemen, go when you're ready.
Thank you, Josh, and thank you very much, Jean-François. Very, very interesting conversation with you. So, for those who have observed the curve, you can see that the numbers are moving again, which means that we have recovered the telemetry from the ground station, the actual ground station being Adelaide, and we see, and we can now monitor and see that we have the shutdown of the EPS engine after the second 30 seconds burst. So we have here the what we call the upper composite, which is composed of the EPS upper stage. The on top of it the adapter, on which is the ATV. The ATV is attached to this adapter. And the brain on the circular outer part of the EPS on top, which contains, of course, the brain, the onboard computer, the inertial measurement units, and all the other electronic and power supply for this upper stage. You can also see that it has some thrust, some burns around the body of the upper stage, which is the little attitude control system, which have 6 thrusters, which allow the upper stage to control and orientate properly the ATV before the separation. We have got the signal from the Awarua station. The Awarua station is situated in New Zealand, and it is the last station before the loss of the upper stage after separation of the ATV. And the upper stage, which will, as I told you, re-enter into the atmosphere after it has accomplished its mission with the ATV. So we are still seeing this very last moment of this mission for the ATV, and after it has completed this mission, the upper stage will make his very last burn after having avoided the ATV orbit. So the DDO calls out saying that all the maneuvers are behaving perfectly. All the maneuvers are performed perfectly and perfectly on time, on target, and as predicted.
Separation coming up, Alex, in just about a minute. Separation of ATV. We had the upper stage burn. The last upper stage burn.
We've been waiting for this moment.
Everything carrying on. It's been a very emotional moment. As you know, the ATV, a huge project for Europe involving a lot of time and a lot of effort for many people. Separation time is 1 hour, 3 minutes, and 54 seconds. That's in just a minute. We'll be over the Tasmanian Sea, picking up where I assume we're still being picked up by the Perth, the Adelaide station, and the New Zealand station, which is I can never pronounce. Then we'll have time after separation to talk about the ATV-3, I hope, unless you've already gone over that.
In preparation for the next flight, which is in some month.
Everything normal. Little bit of tension here in the hall as all eyes are gazing forward onto the computer screens, waiting for the DDO to call out
the last orientations of the composite
of the Johannes Kepler
to reach the
mission,
proper orbit.
The ATV-2 Ariane Space's 200th mission.
Séparation d'ATV2 Johannes Kepler.
Well, there we are, the hall bursting into applause here and smiling faces all around. Successful mission. The ATV Kepler on her way now. In about a week, she should be up joining the ISS for all the docking maneuvers that my friend Jean-François Clairvoy described. This is the way it looks up there. She's pushed away from the mothership. It's a series of springs like with all the other commercial satellites, or is it a different bit there?
Yes, so the springs which are pushing the ATV, and
we'll have a first of a couple of launch replays. You can relive those moments about an hour ago as Ariane left the ground here in French Guiana. All right, Alex, what happens to the launcher now?
So the upper stage has accomplished its main mission, which was the separation of the ATV on its orbit. Now it maneuvers.
Second replay coming up, Alex, and we'll be back.
We'll be back. More. Okay, let's enjoy.
That replay with no sound, but you saw the pictures, beautiful pictures. We didn't think we were going to have good pictures tonight because of the rain, but the sky cleared and we had some marvelous shots of Ariane leaving. So Ariane's final phase.
So as you can see on the screen, the upper stage maneuvers so as to avoid the orbit of the ATV.
Now, this happens on every flight. It's much the same situation. Am I right?
Yes. After we have separated each satellite, of course, we maneuver the upper stage in order not to get as far as possible from the separated bodies, and then it'll stay on ballistic phase, but Mr. Le Gall is...
Mr. Le Gall is approaching the podium to begin the post-launch speeches. Jean-Yves Le Gall.
Madam Minister, dear friends, as you have just seen, Europe has again been extremely successful with the perfect orbiting of ATV-2 Johannes Kepler by Ariane 5. This launch was exceptional. First of all, it was the 200th launch of an Ariane, so a very important step for Europe of space. Then it was the second time that Europe contributed to the servicing of the ISS. And last but not least, it was the first of the 12 launches that Arianespace has planned to carry out this year, 9 in the CSG and 3 in Baikonur. So let me warmly thank all the representatives of the member states who have watched this launch, in particular those who have honored us in joining us today in the CSG. I would also like to congratulate and thank the Director General of ESA for his determination to conduct a space policy that can make each European citizen proud. Because this success is the success of Europe as a whole. Germany and DLR, that has always supported and actively participated in the manned space flights, and that in '95 has been at the origin of the ATV. Italy and ASI, that is playing a major role in the station, and it's an Italian astronaut that next week will welcome ATV on the station, and France and CNES that have developed the launcher Ariane 5 ES and manage with ESA the operations of orbit of the ATV, and of course all the other European states. This success is the success of Astrium and the European space industry that have developed the most complex space vehicle ever developed in Europe and made the launcher that has orbited it, so they've joined the club of the major players. This success is again the success of the CSG that confirms it's now part of the exclusive club with Baikonur, Cape Canaveral and Tanegashima of the space centers servicing the station. It's clear that the quality of its facilities and the quality of the surroundings that our partners find in Guyana contribute to this success. This success, last but not least, is that of Arianespace that has coordinated all the operations, having led to this launch that was the 42nd launch in a row of Ariane 5 and the fourth perfect launch in less than 3.5 months. Madam Minister, if you remember, when I invited you to attend this launch on the 1st of October, I told you that we would launch again 3 Ariane 5 in 2010 and ATV-2 in February. That's what we've just done. And it took us another day, but I mean, we did it. And thanks to the professionalism, the commitment and the efficiency of the operational team of Arianespace that is today organizing the Ariane 5 launches and that in a few months will organize those of Soyuz and Vega. You've met many of our customers, or I've met many of our customers over the past few weeks, and I can tell you that the whole world is envying us today. And let's applaud all of this. Now our mission is over, but we will follow together the progression of ATV-2 Johannes Kepler until the deployment of its solar panels. In the meantime, I've got the great pleasure to give the floor to Mr. Jean-Jacques Dordain, Director General of ESA, and Madame Valérie Pécresse, Minister of Universities and Research. Once again, thank you very much and congratulations.
Madame la Ministre, Monsieur le Ministre, dear friends,
Madam Minister,
I should be short because Jean-Yves said that Ariane has completed its mission. ATV is starting its mission, and I have to go with my colleagues who are looking at the ATV. But already at that point, we can say that this is a new success for Ariane and a new success for all of those who are contributing to the Ariane program. Today we can speak of the 200th
launch of Ariane. Yesterday I was afraid. I was right yesterday to say that to launch at 1913 was not a good hour. 6:50 is much better. And that just to demonstrate that no success is given for granted. You have to force the success. And I must say that those who have forced the success are clearly today the engineers and the technicians who have worked since last night to make sure that we can launch tonight. And I would like to thank all of them, be they from Ariane Espace, from industry, from CNES, and even my colleagues of the Directorate of Launcher of ESA. They have spent a lot of time to make sure that we could launch the Johannes Kepler today, and I would like to thank them very, very, very much. I think that this is your day, and I would like to again to thank you for that. I would like just to confirm that you have seen a launch from ground, but this is true that we got Paolo Despoli live on our mobile 10 minutes ago, and the crew of the space station they have started to see the launch on TV, and they rushed to the cupola. Brought by Europe, by the way, last year, and they have seen the launcher from the space station, and they have taken pictures. So you will get pictures not only of that launch from ground, but also pictures from the space station. And I think that this is not so often that you can get pictures from the ground and from space. So it's a success, and I would like to thank, obviously, the member states. I think that all that would not exist without the member states. I have thanks also the engineers and the technicians. I would like just maybe a word for the ones, the golden oldies who were at the start of Ariane, and there is some of these pioneers today with you. And I see Monsieur Gragueux, who was present at the first council of ESA. So he has attended all council of ESA. And I think that he is unique. And there is Peter Creola also, who has started also, but who is not anymore now in the council. Why Henrik is still in the council. Thank you also to you. Because you have been at the beginning, and if we are here today, it's also thanks to you. So this is a first step for ATV. We are far from saying that this is a success for the ATV. Success will be declared in 6 months from now. So when the mission is completed. But the mission will is starting now, and in now less than 30 minutes the solar panels will be deployed, and when the solar panels are deployed we have power on board, and the real business can start. And after that, as you know, there will be the rendezvous and docking, which is now scheduled on the 24th of February, and Paolo Nespoli will welcome Johannes Kepler on board the ISS next week. So thank you very much. And now I shall go with my colleagues of ATV, because the work is starting for them, and I would like to be with them. Thank you very much.
Merci, cher Jean-Yves Le Gall. Merci, cher Jean-Jacques.
Thank you, dear Jean-Yves Le Gall. Thank you, dear Jean-Jacques Dordain, for all those emotions tonight. And what I'd like to say, I think I also speak on behalf of my colleague Marcivan. I'd like to say that it's a great pride for France, for Europe, to have
experience that, to see that Ariane today is really a reference, to see that the European space industry is capable of designing such a sophisticated space cargo as the ATV. Well, actually, the flight was delayed 24 hours, but it made things even more dramatic. See, when I came, I said, well, it works every time. It's really something so usual, 200th flight. But when you see that it has to be postponed, and you feel the tension, the stress that the team feels every time, I guess, and you know, you're in a state of shock, and you're afraid of failure, and so it gave us even more the feeling of happiness. Today, after this success, I'd like to congratulate all the teams of CNES, ESA, of all the member states, all the engineers and technicians of the space industry who took part in that wonderful adventure, the operational teams of Ariane Space that we are going to be congratulating in a few minutes. I know that they've really worked so hard to make sure that everything would be repaired within 24 hours. I'm really happy because I stayed on purpose just to see that liftoff, and I'm really, really happy to see that it's a wonderful success. So this is a very promising year for Centre Spatial Guyanais, because there will be a lot of launches, Soyuz very soon, I hope, and also soon Vega. So this is a wonderful year 2011, which is starting under the best auspices. So congratulations, bravo, and thank you very much to all of you.
Merci, Monsieur le Directeur Général.
Thank you, Director General. Thank you, the Chairman of CNES, and I would like also to thank the team in charge of the weather forecast, because the weather's great. The weather's beautiful. The weather parameter was green. I know it was a bit difficult to believe that today, you know, with all those showers. But anyway, that was great, and they helped us succeed. So next, we will meet again on the 29th of March for a new Ariane 5 launch, and this time a Yasat 1A for the United Arab Emirates, one of the biggest satellites in the world, and New Dawn for Intelsat and Africa. Thank you and good evening.
Successfully delivering the ATV-2. We're going to close with a recap, a film of some of the major Ariane launches over the years, but stay with us because ESA's Joachim Ebbe, the ATV development part of that team, will be with us, and my friend Jean-François Clairvoy will be with the French. We'll be back with solar panel deployment in half an hour. me do the interviewing. Okay. We have closed the first part of the broadcast. Ariane 5 has successfully delivered, as you saw, the second in the series of the ATV cargo ships. And what we're doing now is we're waiting for the final elements of the ATV mission. This is the ESA part of the broadcast, I guess, because the Ariane part is over. We're waiting for solar panel deployment. So, Alex, before we do that, give us a rundown of how you saw the mission tonight.
I have done several missions with the ESA. I was lucky enough to be program director for Rosetta. I was here with you, Josh, for Herschel Planck.
I remember.
And it's always a huge emotion to participate to this kind of missions.
The scientific missions are very different. All missions are exciting. The scientific missions are a little different, I agree with you.
Particularly different from the usual ones, I would say. However, our job is not a usual one, as you know. And it's for each flight, each flight is a different flight, a different emotion, and different situations to face.
So how did you see the countdown? We had a flawless countdown today, picture-perfect launch, and a letter-perfect countdown before that.
Yes, everything has been fixed from yesterday's anomaly. There was they found the root cause, and actually the teams worked all night long to fix the problem and to resume the operation this morning. Because when the launcher is aborted, then we have to flush the lines. We cannot keep the liquid hydrogen and oxygen inside the tanks, and we have to flush them back to the ground tanks. So it takes hours before we can be back into a safe configuration for the launcher and the satellite.
So tip of the hat to the teams who worked probably all night.
They worked all night, absolutely. And yes, we can thank them, as Jean-Jacques Dordain did, for the work that they achieved.
The launch was without a hitch. Ariane successfully delivering and turning over the mission now to ATV-CC, I imagine, in Toulouse, which is what we have on the screen. Yes. They will assume control, and are they the teams that are going to be monitoring the solar panel deployment?
Yes, and you see Jean-Jacques Dordain is now close to the DMS, the Satellite Mission Director, Nico Deckman.
Right.
He's with his team, waiting for the different activations that will be performed by the ATV, and monitoring that everything is performing as planned.
Now, the solar panel deployment due to begin at 1 hour and 28 minutes after launch. Where are we? That's in about 4 minutes. That's 3 minutes to go, right?
Yeah, 3 minutes to go, and I guess that there is some tension in the Mission Control Center in Toulouse.
And we might have a direct link with them coming up. Shall we bring in Joachim Ebbe, who is here with us? You are from ESA's ATV development team, is that right?
Yes.
Yes. Greetings to you. Thank you for being here.
Thank you.
So we are waiting for solar panel deployment, if I'm not mistaken. Now, why is solar panel deployment coming up at this, it seems to me, an early point in the launch, and why is it taking so long?
No, it comes so late, so early because we are running on batteries, and we have only 2 hours battery, so you have to immediately get the solar arrays out to return the power. Because if we don't get it out in the next 2 hours, we're running out of power.
So the batteries on board the ATV can only provide power for
2 hours.
For 2 hours.
That means 2 orbits.
2 orbits. So you're right. The solar panel's rather important.
Yes.
Now, how important is the launch window? Well, there was no launch window, but the launch time is gauged towards getting the payload, the ATV, in a position where the solar panels can be deployed and receive energy from the sun. Am I correct? Is that there's a calculation there? Is that right? You don't look like I've said that right. Explain it. Explain the relationship between the fixed orbit time and the solar panel deployment for us.
You mean the fixed orbit time now where we are? Okay. So what you do now, you employ them and you start immediately to go to yaw steering, earth pointing, to adjust the solar rays and the sun to recharge the battery. That's what you do now. Because the ATV will go in attitude control. In the attitude control is yaw steering, and you start immediately with the computer to align the solar rays to the sun to get the power back.
I see. Okay, so you have to do this before
yes.
2 hours.
Yes, because now otherwise you run out of power.
Okay. Was this the role that you played in development of the ATV? Did you work particularly on this subject, or did you work on another aspect?
No, I was avionics. I was involved in avionics.
Avionics. Okay. Well, tell us about that then. Tell us what you did. The avionics is what? Is it the propulsion systems?
Avionics is quite a complex mechanism here because it contains of computers, acquisition units, sensors, gyros, GPS, and of course the whole system is built up to be failure tolerant. So that means you have 3 computers. You have
on board
3 computers. The 3 computers are doing the same software, doing exactly the same, and they have a voting concept.
When you say they're doing the same, does that mean they're, what's the word, redundant, or
they're redundant?
Backups?
They're redundant and voting the results. And if one computer, let's say, disagree, he gets automatically voted out. So that means you go then from 3 to 2 computer system. But okay.
We're going to have, we'll be back with more from Joachim, part of the ATV development team. We're going to go in a minute to an interview we had with Bernard Cabrière down there in Toulouse. He's Assistant Director of Operations at CNES Toulouse. I think you'll find this interesting because he told about some of the experiences on the ATV development. Back with more.
Well, first of all, thank you to our friends from Kourou and the ones working on the launches for having positioned that second big baby of the ATV family. I believe we'll get to see them often this year because at the end of the summer we'll position also the 2 Galileo spacecraft from Toulouse on the first Soyuz launch, and with our colleagues from ESOP, and at the end of the year we'll get ready to launch the 3rd ATV Pléiade and the 4 ELISA satellites also in Kourou. So see you soon, Kourou. ATV is a very complex vehicle. Only by its size, 20 tons, 10 meters, it's quite huge. And also, those are operations we're not used to. Docking onto a manned flight, a dialogue between 3 control centers. So with Jules Verne, we had to fine-tune all of that, and it was very hard work for all the teams to design that system. Since Jules Verne, we worked a lot to confirm that brilliant success and to do something that would be durable, because we'll have 5 vehicles to launch. So we worked on making hardware, software, networks more robust, and we worked on training teams because our launches will be less spaced out. So we will be developing a training academy to already succeed in that docking, that positioning with Johannes Kepler. And then when docking is completed, we'll start training the 3rd ATV Eduardo Almaldi, which will be launched next year.
All right, that's Bernard Cabrière, Assistant Director of Operations at CNES Toulouse. We have another interview coming up in about 2 or 3 more minutes with the project manager for the ATV operations at CNES, someone you probably know, Joachim Marshall Van Hove. I'm sure you've worked with him. So we're going to be hearing from him in a moment. But for now, carry on, unless you had a question, Alex, or shall we continue with the...
I had a question for Joachim. So,
go ahead.
How much time does it take to develop an ATV program, such a huge and complex program?
No,
well, approximately. I mean, it's not a 5 or 10 years program. It's
we started
more than that.
We started 95 with the first ATV 95.
For Jules Verne.
The first study was done with ATV 95, where it was called Ariane transfer vehicle. Not automated. It was
same initials.
Yeah, but same initial, but it was Ariane transfer vehicle. It was 95, even before we had studies. So.
And that's before the space station was up.
Yes, right? It was a type of a generic Ariane transfer vehicle, and then I think after.
But used to be to transfer what? From what to what?
let's say it was to transfer, let's say cargo to the station, because we built here an MTFF, we built the Columbus, we had here a huge program.
Okay.
So, but the real program started 98, 99 we started development.
Okay. Back with more from Joachim, with very interesting looking back on the ATV, which started, you said, in 1995, so it was launched 13 years later.
Yes.
So we'll get back to that, but we're going to go to our second interview. Marshall Van Hove, project manager for ATV operations, also with CNES. We're back with Joachim and Alex while we're waiting for solar panel deployment.
Now that the ATV has been separated from the launcher, the role of the ATV-CC really starts. We've been waiting for this moment for a month. The control center will now take the handover of the vehicle. We will first make sure that this separation and the first automatic activities on board the ATV go on fine, that the configuration is correct, that the solar panels deploy, communication masts deploy as well. Then we'll move the vehicle, activating its thrusters to an orbit that will slowly, day after day, in 8 days, make it to the station for our final rendezvous. We will use these 8 days to finalize the preparation of the vehicle for this rendezvous with the two main activities: select the thrusters, a group of engines that would allow us, in case of danger during the approach phase, to take the ATV away from the station as quickly as possible. And besides, we will finalize the mechanical preparation to guarantee this rendezvous with the station. Once docked onto the station, the ATV will play its role of cargo ship, providing services to the station, among other things. It will control the station altitude, increasing it from time to time. It will deliver fuel. It's used for this purpose as well, and eventually pull away from the station and be destroyed above the South Pacific with the waste the crew will have put on board. This is the last phase of the mission. It's not as noble, maybe, but it is as necessary.
Joachim Ebi of ESA, you said you're on the link with the ATV CC Toulouse, which is on the right-hand part of your screen, and you said that you heard the confirmation of the beginning of the solar panel deployment. All right, so that takes how long?
10 minutes.
10 minutes. Why does it take so long?
Yeah.
Why?
Because the solar arrays are, let's say, it's a box called TCU, it's a thermal control unit. There are 4 TCUs. And
a TCO, sorry, is what?
It's a thermal control unit.
Thermal control unit.
Yeah. And we have 4 TCUs. The TCUs get the order from the computer, and the TCUs will start. That means the solar arrays you are plugged in, they have springs, and they are thermal knives. So you have thermal knives, and you deploy it. And of course, it takes time to deploy 4 different unique solar arrays up to the Estode. That takes in total 10 minutes.
10 minutes, okay. Yeah. And all that's being monitored by Toulouse?
Yeah, because what we have now, we have also now telemetry via the TDSS, so they can monitor the telemetry data to see that the solar arrays are perfect deployed.
Good.
TDSS, the tracking and data satellite, yeah.
That's the GPS, that's the NASA
It's a NASA.
It's a semi-commercial fleet now, isn't it? Or is it still NASA?
It's commercial. It's commercial. In old days it was pure NASA, but now it's commercialized. Mm-hmm. So the ATV data are sent via TDSS to White Sand, and from White Sand via these are linked to Toulouse. Yeah, so it's called IGS, so that is...
I had another question for our
Jump
guest.
in any time.
Joachim, what was how did you manage the contribution of the US and the Russians in the designing the ATV?
Yeah, because you have not only science. That's a good question. You have not only scientific challenges, but maybe cultural challenges, because the Russians are good at things, and you have to. It's like Jean-François Clairvoy had to design the failure, the malfunction chart for Russians, Europeans, and Americans. Did you encounter the same sort of, I won't say problems, but issues?
No, I think with the Russian, in the beginning, the problem with the Russian was the language barrier, because all the meetings have been done in 2 languages. So we have, for every meeting, we have translators. It's now deployed. Yeah.
From the look of things, we may have successfully solar panel deployment. People are, Mr. Legal is clapping. You seem to think so, Joachim.
Yeah.
Did you hear something on the...
No, the back, but I guess from the reaction. I didn't hear something in the voice.
Donc, à partir de maintenant, nous pouvons recharger les batteries qui se déchargeait très rapidement sans les panneaux solaires. Et à partir du moment où on a la puissance à bord, je dois dire que maintenant nous pouvons contrôler l'ATV. Donc ça n'est pas encore fini, mais le bébé se porte bien. Voilà, merci beaucoup.
Jean-Jacques Dordain saying that we can now recharge the batteries, as Joachim said, because we now have the energy coming from the solar panels, the four solar panels, which are successfully arrayed now. So the pretty much entire functioning ATV is on its way. For the next 8 days, she'll be trying to catch up with the ISS, 22,000 kilometers ahead of it, I think. And then she has to raise up about another 100
kilometers.
100 kilometers, is that the figure?
That takes time.
Yeah. Okay. Just a couple of, before we leave you, just a couple of things. You started to talk about the cultural differences now. I think that's interesting. Go ahead. There's always translators on the Russian side.
Yeah, because
that slows things down, I guess, huh? In meetings.
I think the Russians, I think they have a great history in space, but they had another way to do it like we did. Yeah. So we have to find ourselves together, let's say, to have two different cultures, how to make space hardware, and I think ITV shows that we successfully reached the goal. Yeah.
I think you're right. ITV shows that we successfully...
For example, the docking adapter they have, the Russian docking adapter, when it was presented to us, it was a very old design relay logic. Was a wash machine relay logic, but we could not put this in ATV from the weight, from the volume. It was boxes, let's say half a cubic meter.
But it's a system that worked.
Yeah. But it was for ATV. It means from the size, from the volume. So we did a redesign, which is called REX, it's Russian electronic system. So we redesigned with the Russian the complete docking adapter. We have now an electronic type which is much more sophisticated, because the old one was not possible to install the old one in ATV. So we did a couple of redesigns on the Russian hardware.
And we have the same kind of experience on the rocket side, because we are now working for Soyuz, and we have also the Russian teams here. And I must say that working in such a multicultural context is really very exciting.
It's exciting. It's not easy, but it's very fulfilling, I would imagine.
Yeah, a typical example is we found out Russian have almost had very low experience in designing in vacuum.
Okay, we're going to think. All right, we're going to leave you, I think, with everything successfully accomplished. Thank you to Joachim Ebi from the ATV development team at ESA. Any last words, Alex?
Well, my last words will be that, as I told you, each flight is a new emotion. I heard Jean-François saying that he would cry at each time he sees the Earth from space.
Something. Huh?
I wouldn't cry, but I really feel
almost. We're going to leave you before Alex breaks into tears here. The next launch, I think Mr. Gall said, is at the end of March. We'll be here. We hope you will be too. Joshua Jampo with Alex Madembasi. Thanks for being with us.
Goodbye,
we hope you enjoyed
everyone.
it. See you next time.
See you next time.